We are starting Demster Shafer theory. Is afterwards Bayesian network theory. What is this? It is a generalization of Bayesian network. Generalization of Bayesian network. This new approach considers a set of propositions and which assigns to each proposition of them an interval. BST considers two things. Considers an interval between belief and plausibility. Let I will explain what are those. Now, given an evidence M1, given an evidence M1, belief of M1 can be written as belief of M1. Okay. Now, this belief is given by practitioners. What if the evidence is such that we have a very high belief? We can write it as 1. Fine. Now, what is plausibility? Plausibility is nothing but plausibility is of M1 can be written as PL of M1, which is equivalent to 1 minus belief. What is the belief in the opposition of this hypothesis? Here, M1 is the hypothesis. Hypothesis. Fine. Here, M1 is the hypothesis. Now, what is belief is? Belief is strength of evidence in favor of hypothesis. Now, we can write as belief of M1 is equal to strength of evidence in favor of hypothesis. Favor of hypothesis. What is plausibility? PL of M1. It is strength of evidence. It is the same thing. Strength of evidence in favor of hypothesis. 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 Given evidences against the hypothesis. Given evidence against the hypothesis. Against the hypothesis. The hypothesis. Now we discuss few examples of belief of M1 and plausibility of M1. If suppose in question we can give you the certain evidences, and what does do you mean? Like suppose in example we have give you that we have the interval 0 comma 1. What do you infer? So with this example interval we know that belief of M1 is 0 and plausibility of M1 is 1. Now, what does this mean? Belief of M1 is 0 means that no confidence in the hypothesis. No confidence in hypothesis. Confidence in hypothesis. Hypothesis. Now, how we calculated plausibility? We know that the plausibility formula is plausibility of M1 is equal to 1 minus belief of negation of M1. Fine. Now, plausibility is 1. So, 1 minus belief of negation of M1. So, therefore, belief of negation of M1 will be equal to 1. What does it mean? That, sorry, belief of M1 will be 0 here. Belief of negation of M1 will be 0. Now, what does that mean here is that no confidence, no confidence against the hypothesis, also against the hypothesis. Hypothesis. What does that mean? That we are at total ignorance. We are at total ignorance. Ignorance. Fine. Because we don't have any confidence in support of hypothesis, and we also don't have any confidence in negation of hypothesis. Fine. That's why plausibility is 1. Okay. Plausibility of a hypothesis will be 1 only in the case when the evidence in negation of hypothesis is 0, or belief in negation of hypothesis is 0. Fine. So this is 0 here. Now again we will take one more example. Like we can take one more example. If the interval is given as 0, comma 0, what does that mean? It means that belief of M1 is 0, plausibility of M1 is 0. Still, it means no support for hypothesis. No support for hypothesis. Hypothesis. Plausibility of M1 0. How it is possible? Plausibility of M1 is equal to 1 minus belief of negation of M. Now we have 0, 1 minus belief of negation of M1. So we can, therefore we can say that belief in the belief against the hypothesis is 1. So we have a confidence that hypothesis is not true, or total disbelief in the hypothesis. Fine. Same thing we can have it like we have 1 comma 1. If the interval is like this, what does it mean? That belief in hypothesis is 1. Fine. It means full support for hypothesis. Full support for hypothesis. Hypothesis. And plausibility is 1. We have seen earlier, plausibility for M1 is 1 only in the case, therefore belief in negation of M1 is 0. Then only plausibility can be 1. Fine. So we can say that when the interval is 1 comma 1, we can say we have full support for the hypothesis. I believe this is clear. If the question comes in the examination, you can easily write things like what is the inference. If the belief is 1, what do you mean by belief of 1? If the plausibility is 1 and belief is 0, what do you mean by it? Okay. So we write it in this interval form. Now, how this DST, how DST versus Bayesian. Demster Shafer theory. Now, how? Suppose we have 3 mutually exclusive hypotheses A, B, C. We don't have any information. Okay, starting information. So, what Bayesian does? In Bayesian, we give prior probability to each one dt of 0.33 to each But in DST, we have an interval of 0, comma 1, that is total ignorance. We don't know which hypothesis will have any impact. Total ignorance. Whenever we will get any evidence, we get any evidence, whenever we get any evidence, we shrink the interval. Okay, so we can say that as evidence is gathered, this interval changes. This interval changes. Changes. Fine. Now, Bayesian approach says that we have information before having evidence. Now, this is the contrast between DST and Bayesian approach. That here Bayesian approach says that before evidence, we can give probability of 0.33 to all the three hypotheses A, B, and C. But in DST, this is not the case. DST will be giving zero value to the belief to each hypothesis, and it will say that we have an interval of 0, comma 1 where we have total ignorance. We cannot figure out which hypothesis has which confidence we have. Fine. Now, uh, starting with an example for DST. Let's start with an example of DST. Before starting, let's discuss some notations in DST is, that is example for DST. Now, notation for DST is theta. It is called frame of discriminant. Frame of discriminant. Frame of discriminant. Fine. Remember this point. It contains it contains all possible mutually exclusive hypotheses. Mutually exclusive exclusive hypothesis. Hypothesis. Okay. Now example, like for a problem. Okay. Problem. We have uh, a disease. This problem relates to identification of a disease given a patient is suffering from few symptoms. Okay. Now we have theta. Doctor has advised that mutually exclusive events like theta. We have all, that is allergy, flu, cold, and pneumonia. Now, what does this set means? That after seeing the system, doctors figure out that only these are the four possibilities. So it put in the inside this frame of discriminant. Okay. Now we can have we now what we require is to assign beliefs to each element. Now beliefs can be assigned to each element or subset of elements. Why subset? Because like any one evidence, like the patient is having fever, it is, you cannot say that fever only belongs to flu. It can belongs to either flu or cold, or it can belongs to pneumonia or flu, like this. So we have to see this thing into account. Now, as and when the doctor gather evidence, I write all these things so that you can remember. Now, as and when doctor gather evidence, gather evidence, okay, it attaches some measures, it attaches some measures of belief to the elements of theta, to the elements of theta. Fine. That is subset of uh, that is subset and these elements can be the subset of those elements inside theta also. So this belief. Now suppose doctor can assign some value to allergy, some values to flu, to cold, some value depending upon what the evidence doctor is seeing. Fine. Now, since you know that theta contains mutually exclusive element, okay, using different slides, since theta contains mutually exclusive element, exclusive elements. What are mutually exclusive elements? That those elements cannot happen at the same time. Okay, it means here what does it mean? That two disease cannot happen at the same time. The patient must be suffering at least from one disease. This is our assumption, mutually exclusive elements. Now what we are seeing is that if theta contains an element, if theta contains an element, then we have to assign then we have to assign MP, this is MP, where P is subset of theta, okay, and this is called belief value, belief value, okay, fine. P can be P can be singleton, that is containing only one element like allergy, example, or subset, like flu and cold, example. So what are the values P can take? P can take 2 raised to power n values, or we have a total subset of, okay, we can have a total subset if we have 4 elements in the theta right now. In given example, theta contain 4 elements. So total combination we can have equals to 2 raised to power n. Now you must question that whether we have doctor will assign values to all the combinations like empty set, all the four singleton set, then combination of two set, then combination of three set, and lastly the combination of four sets. Now, no, answer is no, because evidence doctor with his own experience assign belief value to certain sets of that 2 raised to power n power set. Fine. So 2 raised to power in this case will contain 16 subsets including empty sets, simply substance. Now after each element, doctor will choose one subset and assign some belief that the problem can lie in this subset. Okay. Fine. Now we have theta contain mutually exclusive and have 2 raised to power n number of subsets inside the theta. Remember this point. We can ask in MCQ like this, MCQ, if uh, if theta has 5 elements, what are total number of subsets? Number of subsets. Answer. So answer will be 2 raised to power 5. So answer will be 2 raised to power 5. Fine. This way you can answer certain MCQ question. Now suppose doctor assigns some values, uh, some out of 16 doctor assign 7 subsets, some values, some belief values, some belief values. Important point. This is important. Sum of sum of all belief value is 1. You may ask what will be the belief values of all other 9 elements. So all other subset have belief value of 0. Value of 0. Okay. Remember these 2 points. That sum of all belief value for a given hypothesis in the subset theta will always be equal to 1. Fine. Fine. Now let's start with our problem. Now, step 1. Step 1. Now we have no information. We have no information. Okay. Or evidence. Okay. To choose between 4 hypotheses. Choose between 4 hypotheses. That is allergy, cold, pneumonia, and flu. Fine. So now only thing we can have is we can write this like that we have theta and its value is 1. What does this mean? That doctor has the confidence. What does this infer? That doctor has confidence. Doctor has confidence that the disease will lie in theta only. The disease will lie in theta only. Okay. This is the confidence doctor is having. Fine. Or we can say in other words that actual value must be any of the element of theta only. Fine. Now next step, we gather certain evidence. Step 2, we have, and write it as step 2. Now one evidence came, that is patient is suffering from fever. Patient is suffering from fever. Okay. Patient is suffering from fever. Now doctor with his experience can give that fever can relate to what diseases. Now doctor with his experience will give that flu, cold, pneumonia, okay, a belief of 0.6. Now this is, what does it mean? This is will be given to you in question. If suppose any question will be asked, we will give this kind of question to you. Fine. Now, and doctor has the belief that after seeing the evidence 1, that 0.6 is the belief that the diagnosis will lie either in flu, cold or pneumonia, or rest of the belief is that 0.4 belief that it will lie in the rest of the cases. Fine. So this becomes our M1, okay, M1, that is measure of belief. First, after seeing the first evidence. Fine. What we have done. So the new hypothesis. So this will be become after seeing the first evidence, M1 will become our new hypothesis. Okay, where we have assigned initial hypothesis theta is assigned 1, that is something will be inside theta. Now the first evidence came that after first evidence doctor has decided that the belief that the probability that or the not we say probability, the belief that the diagnosis will be in flu cold pneumonia will be 0.6, and for rest of the cases it will be 0.4. Now this is M1. Now at this point doctor has assigned appropriate belief to the set flu cold pneumonia. Remainder of belief is still in larger set. Fine. Now note, important point is here. Suppose M1 and M2 are two hypotheses given. Generally, these two hypotheses will be given to you initially. What are the evidences? What are the hypotheses? And theta set will be given in the question. So what will happen? You can make a further hypothesis M3 using this M1 and M2. How you can do? You can use this formula. M3 is equivalent to X intersection Y. What are the intersection? We will explain you right now. What are the intersection of Y and what are the values you are getting here? Multiply by the belief values for those M1X into M2X upon, this is the plausibility condition, 1 minus, okay, sigma of X intersection Y, wherever X intersection Y is empty. Find M1X into M2X. Now use it in this formula for getting new hypothesis if two hypotheses are given. This is the formula for getting two hypotheses if M1 and M2 is given with their sets. Like here this is M1. There are two sets, flu, cold, pneumonia and theta. Likewise, M2 will be given after another evidence. So if you have two evidence, then you can find create a third hypothesis using these M1 and M2. Let's do it. Fine. Let's do it. Do it next. Now, M1 is given as M1 we have been given this. Doctor has assigned flu, cold and pneumonia. Okay, equal to 0.6 and theta as 0.4. Now suppose new evidence evidence comes. Now this new evidence is patient is suffering from running nose. Suffering from running nose. Okay. So we will have doctor will assign or figure out the subset from where this running nose evidence can fit. So this running nose doctor assigned that it can be due to allergy, it can be due to flu, and it can be due to cold. It is not there. It is not considering pneumonia, and it gives a belief value of 0.8. Now this will be provided to you. Don't worry about it. And this is 0.8. Then rest will be 1 minus its belief value, because total sum of the belief value will cannot be greater than 1. So this becomes your M2. Okay, this becomes your M2. Fine. This is your M2. Now, how you will find M3? Now, listen carefully. How you will find it? Now, I will make a table here. You write M1 values here and M2 values here. Okay. What are the subset? I will write in short form. Subset for M1 are flu, cold, and pneumonia. We can write it as F, C, C, and rest is theta. What are its belief values? For FCP is 0.6 and for theta is 0.4. Now M2 you write it. M2 or allergy, flu and cold. We have allergy, flu and cold, and we have theta. So we can have such table like this. Draw proper lines. We can have this table. Okay. Now AFC value in M2 is given as 0.8 and for theta it is given as 0.2. Fine. Now what you do is, now what is the previous slide which you are talking about? Here you see in the numerator part. What are the intersection means common values in M1x and M2x. Fine. So here common values for here FCP and AFC. What are the common values? Only F and C. So we write F and C. Now what will be is new belief value is multiplication of their belief values. Multiplication of their belief values is 8 6 are 48, so 0.48. Fine. Now denominator term is only considered when you have any phi, that is x intersection y, you are getting any phi value. Now we will consider it later after completing the table whether getting any phi value or not. Okay. Now here AFC, FC is common. Now again theta and AFC. Theta contains all possible exclusive events, so it contains AFC also. So the common term here will be AFC only. AFC, and its new belief value will be 0.8 into 0.4 is 0.32. 0.32. Fine. Now theta and FCP. Theta contain also common will be FCP. FCP, and its new belief value is 6 into 2 12 0.12. 0.12. Now theta and theta all common, theta will be there, and its new belief value is 4 to the 8 0.08. Fine. Now since you see after checking all elements, this is first subset, second subset, third subset and fourth subset, all subsets are non-empty. So here this value will be 0, because here we don't find any elements which are of phi non-empty. If this value is 0, then this is 1, and so we will have all the values which are there in the table. So no need to change. No need to change here. Fine. Now our M3. M3 contains hypothesis 4 things. FC with a belief value of 0.48, AFC with a belief value of 0.32, then we have FCP with a belief value of 0.12, and theta with a belief value of 0.08. Fine. Now this is M3. Now this M3 we have computed after getting two evidences that patient is having fever and patient is having running nose. Now we have computed the belief value for four subsets. Now, again, if in the question is there, now if suppose question is giving only two evidences, you have to stop there and you have to give this answer that after getting two evidences or two information, this is the hypothesis, final hypothesis. We concluded that we have a belief of 0.48 that patient can have flu and cold. We have a belief of 0.32 that patient has a allergy, flu and cold, or we have a belief of 0.12 that patient has a can have flu, cold and pneumonia, and rest is theta. Now suppose in the question is there is another evidence, like we have another evidence another evidence we have another evidence. Now this evidence will create M1, M2 we have done, M3 we computed. This another evidence will create an hypothesis M4. Fine. The evidence is all goes away, problem goes away, goes away, fine, when patient, when patient goes on a trip or abroad. Patient goes on a trip or abroad. Now, this is a very important evidence. Doctor thinks that that problem is going away when the patient is going out or changing its environment. So, doctor will definitely give more weightage to allergy, because allergic reactions can be based on environment, and like suppose you are from south, you go to north, very cold and hot environment. Bangalore environment is very good, not too cold, not too hot. So in this case, we can think that environment is having a great effect on the patient. The doctor may assign a subset, that is allergy, a belief of 0.9 after seeing this evidence, and rest as 0.1. So sum of all the subset for each hypothesis will always be 1. Remember, whether it is M4, whether it is M3, whether it is M2, each sum of each element of these hypotheses will always be 1. Whether you sum it 0.48 plus 0.32 plus 0.12 plus 0.08 will always be 1. M3 for M2 also it will be 1.8.21. For M1 0.6.4. So here it will always be 1. Now we have only three evidences are there. After third evidence, we have arrived at this M4. Now can we compute M5 using this? Yes, we can compute M5. Now we can compute M5, that is hypothesis 5, using M3 and M4. Okay, how we do it? You write M3 values here and M4 values here. So what are M3 values? FC, AFC, FCP, CP, and theta. What are their corresponding beliefs? For M3 we have calculated 0.48, 0.32, 0.12, and for theta we have 0.08. Same for M4 we have allergy and theta. Now you make the table. This table making is very important. Now how? Now you see, A and FC combine M3 and 4. Is there anything common? No. Now you are seeing we are getting empty set. And for empty set we have to give for A in M4 for A we have is 0.9 and for theta we have 0.1, that is belief. Now for this, after this interaction, okay, we will get this empty set. And what is the value of this empty set? 0.48 into 0.9, it is around 0.432. Okay, so this you have done it. Now AFC and A, we will have A. Okay, so what is this? A 0.32 into 0.9, it is around 0.288. 0.288. Fine. Now A and FCP, again no evidence, no common thing. FCP and A, empty set, we will get empty set, no common. So multiply, but you still have to multiply the beliefs. 0.12 into 0.9 is 0.108. Okay. Theta and A, we will have A only. A only. What is 0.8 into 0.9? It will be 0.072. Same thing we will write FC because it is theta, everything will be repeated. FC can write AFC. Okay, you can add FCP. Okay, and theta here. Now what are their new belief values? 0.48 into 0.1, only you add 1 0 extra. 0.048, it will be 0.032, it will be 0.012, it will be 0.008. Now you see, I will use different color to mark here. Now this is empty, this is empty. Fine. So sum of empty subset total, I will have empty subset total belief in M5 for empty subset is 0.432 plus 0.108. So what you are getting? 8 plus 2, 10, 0, 1 either 4, 5. So 0.54. Now, what do you mean by this? That after getting 3 evidences, you are getting a belief of 0.54 for against, that is for empty set. That is empty means you are against all the hypotheses. There is nothing in the real or allergy, flu, and that thing. You are not getting any support. And for rest of the values, you are getting 1 minus 0.54, that is 0.46. Okay, what do you understand here? 0.54 is for empty set and 0.46 for rest of the set. So this is not demanding. Here comes the rescue. This is the condition of plausibility. Fine. What we will do? We will figure it out. Now we see, I will write here in red. What is the belief of A in M5? See, A came here, A came here. Anywhere else A came? No. You add it. 0.288 plus 0.72. 0.072. What will be the value? 8 to 10, 1 idhar, 9 plus 7 is 16, 1 idhar, 3. So it is 0.36. What is the allergy? For allergy we got it. For FC, any double value of FC? No. For FC we have 0.048. For AFC, we can see that we have 0.032. For FCP we have 0.012, and for rest we have 0.00. Now this is the final M5 subsets of M5. This is the final subsets of M5. But you can see in this subset we have empty subset also whose value is 0.54. Now this is of matter of concern. Now here back in the table you see how we calculate it. Whenever empty subset is given, you add those all values, find it 0.54, we have got it. Here what we'll do? Normalization. Find the values for each subset. How? That is, like I will give you an example. For A, we have for subset A, what is the value in belief we have got? 0.360. Okay. So it will be numerator will be 0.360 upon, now empty subset we are minus 1 minus 0.54, so we will have 0.46. So you divide it. I am dividing it right now. Okay, so it will be around into, so it is around 0.78. This is sometimes called normalization also. So after normalization, we will get many values. So 0.78 for A. So we will do similarly for all. We will write here. We will write here. For A, we have what values we are having? 0.360, 0.360. So what we will do? We will divide 0.36 divided by 0.446. So it will be 0.78. Now same thing we will do for other values, that is for FC, AFC, FCP. For FC, okay, for AFC, AFC, for FCP, FCP, for theta also, theta also. Okay. Now we will not consider, this is called normalization. Fine. We will not consider singletons because we know that the evidence will lie here only. So what will the value FC? 0.048. So 48. What is the value of AFC? 0.032. 032. The value of FCP? 0.012. 0.012. What is the value of theta? 0.008. 0.008. Okay. You will do 0.008 divided by 0.46. What is the answer? Same thing you will do 0.032, 0.46. Same here you will do this. So 0.012 divided by 0.46. Same here you will do 0.008 divided by 0.46. If we don't get any empty set, then we don't need to divide it. Remember this point. So 0.048 divided by 0.46, it is around 0.104. Okay, next one is 0.032 divided by 0.46, it is around 0.032 divided by 0.46, it is around 0.069. Then we have 0.012. My calculator is slow. Is around 0.002. This value is 0.08 divided by 0.6 is around 0.07. Okay, now since we are not at all concerned, this is called normalization of values. Now you can see we have this much of values where we can clearly say allergy has, after getting three evidences, allergy is giving the maximum belief. So we can, doctor can easily compute that patient is suffering from allergy. This is what is Demster Shafer theory is all about, where based on evidences, as and when evidences are gathered, you create your belief. Now how the belief values are given, that is you don't have to worry. Belief values are given by practitioners, and in the question in examination normally we can give you like how questions can come in examination, understand, like M1 hypothesis we can give you that x y is a one subset, x is a one subset, and theta is one subset. Okay, its value is something, its value is something, its value is something. M2 is there, this is a subset, this is a subset, so this is subset, theta is there, this is z x z. Okay, now calculate M3, how many subsets will be there in M3 and what are their values. This kind of situation we can have in the examination, not more than this. So your task is you understand how these values are calculated, revise the video, check on the video, if you stop it whenever you are not understanding. Fine, this is it on DST. Thank you all.